Recurring and terminating decimals. Recurring and terminating decimals. Very, very good concept, sir. Recurring and terminating decimals. Recurring and terminating decimal. Each and every point, whatever I am specifying, is of extreme importance from the exam perspective. Listen carefully. Recurring and terminating decimal. First of all, why these decimal came into picture? First thing, rational number. What is a rational number? Rational number, any number which can be represented in the form of P by Q. When P and Q are integers, when P and Q are integers, Q not equivalent to 0. When Q not equivalent to 0, then it is called a rational number. A rational number is in the form of a fraction. Numerator will be P, denominator will be Q, both are integers. P and Q are integers. Both can be positive integers, both can be negative integers. One can be positive, one can be negative, but the denominator cannot be equivalent to 0. Denominator cannot be equivalent to 0. Second point, proper fraction. Proper fraction. Listen carefully, sir. Proper fraction. A proper fraction is where P is less than Q. A proper fraction is a fraction where numerator is less than denominator. In simple language, it is less than denominator. It is less than denominator. Improper fraction. Improper fraction. It is not proper. That means numerator is not less than denominator. Numerator is greater than denominator. Numerator is greater than denominator. If P is equivalent to Q, if P is equivalent to Q, then it becomes a natural number. If P is equivalent to Q, 2 by 2 it is 1, 3 by 3 it is 1, 4 by 2, either P equivalent to Q or Q is a fraction of P, then it will result in a natural number. Then it will result in a natural number. 1 by 2, 3 by 4, 5 by 6. Because we are taking a ratio, one part out of total parts, I will work with the positive values. 7 by 3, 13 by 9, 23 by 5. These are all improper fraction. For me, what is very, very important is the denominator. Denominator. Under what condition I will get a terminating decimal? Under what condition I will get a recurring decimal? Up to maximum how many digits? The digits will be repeated. Everything we will discuss right now. P by Q. A rational number. A rational number will be of the form P by Q. P and Q are integers. Q not equivalent to 0. Now, listen carefully, sir. Listen carefully. A rational number, a rational number, a rational number will be of the form P by Q. A rational number will be of the form P by Q. P by Q. Very, very important key point. Very, very important key point. P and Q are integers. P and Q are integers. P and Q are integers. First key point. If Q is taking only powers of 2, only powers of 2, or only powers of 5, or only powers of 5, or only powers of 2, 5, only powers of 2, 5, then I will get a terminating decimal. Then I will get a terminating decimal. A terminating decimal is possible when P, Q are co-prime to each other. P, Q are co-prime to each other. P, Q are co-prime. 4 by 20, make it into 1 by 5. When P and Q are co-prime to each other, when it will be co-prime? When their HCF it is 1. HCF of P comma Q is equivalent to 1. Then the numbers are said to be co-prime to each other. A decimal is of two types. Terminating decimal, non-terminating decimal. When it will be terminating, it will only terminate when the denominator is a power of 2 or a power of 5 or the powers of 2 and 5. Then when it will result in non-terminating decimal, when I will get a non-terminating decimal, when the decimal will not end, when I will get a non-terminating decimal, when Q takes any power, when Q takes any power other than 2 comma 5. Very, very important, sir. When Q takes, when what is Q? Q is the denominator. If the denominator is taking any, if the denominator is taking any powers other than 2 and 5, any powers other than 2 and 5, then I will get a non-terminating decimal. Then I will get a non-terminating decimal. One is a terminating decimal, another is a non-terminating decimal. Next slide we will discuss about a terminating decimal, then we will come to the non-terminating decimal. If Q takes only powers of either 2 or 5 or both the powers of 2 and 5, then I will get a terminating decimal, else I will get a non-terminating decimal. Listen carefully, sir. It's very easy to understand it conceptually. Terminating decimal. Terminal is endpoint. Terminal, it is an endpoint. That means after dot, there is a step where the digit will stop. Terminating decimal. 1 by 2. 1 by 2 is 0.5. 1 by 2 is 0.5. 2 is 2 power 1. 2 is 2 power 1. After dot, at one digit that decimal stopped. 1 by 2 square. 1 by 4. Which is 0.25. After dot, exactly after 2 digits, the decimal got stopped, which is the power of 2. Similarly, 1 by 2 cube, 1 by 8, 0.125. Exactly after 3 digits, the decimal got stopped because of the power of 2, which is 3. Now, once you understand this, 1 by 5, 5 power 1, 0.2. Exactly after dot, at one digit it got stopped. Then 1 by 5 square, 1 by 25, 0.04. Exactly after 2 digits, it stopped because power of 5 is 2. 1 by 5 cube, 0.008. Exactly after 3 digits, it got stopped. 1 by 2 into 5, 1 by 10, it is 0.1. Exactly after one digit, it got stopped. Why? Because LCM of 1 and 1 is 1. Similarly, 1 by 2 square into 5. Listen carefully. 1 by 20, which is 0.05. 0.05. Listen carefully, sir. What are the powers for 2 and 1? 2 and 1, it is 2 and 1. What is the LCM of 2 comma 1? What is the LCM of 2 comma 1? 2. Exactly after 2 digits, it got stopped. Suppose if it is 1 by 2 cube into 5 square, which is 1 by 8 into 40. 1 by 8 into 40. Now see here. What is this power? 3. What is this power? 2. What is the LCM of 3 and 2? 6. Exactly after 6 digits. 1, 2, 3, 4, 5, 6. After 6 digits, it will stop. After 6 digits, it will stop. This slide is an extremely important slide. Very, very important slide, sir. That means if it is 1 by 2 power p, it terminates after p digits. It terminates after p digits. after dot. Are you all with me? After dot, exactly after p digits, it terminates. It is not only valid for 1 by 2 power p, it is also valid for 1 by 5 power p. Suppose if it is 1 by 2 power 5 p1 into 5 power p2, then it terminates. Then it terminates after LCM of P1 comma P2 digits. Very, very important, sir. After dot. After dot. After dot. Is it clear? See, easily you can say it is 3 digits, sir. Why? Because 320 is 1 by 32 into 1 by 10. It is 1 by 10 into 1 by 32. 1 by 10 is 0.1. 32 is 2 power 5. After dot 5 digits. After dot 1 digit. After dot 5 digits. Totally terminates after 6 digits. I hope it is clear. So if it is 1 by 2 power 5 P1 into 5 power P2, it terminates exactly after LCM of P1 comma P2. P1 comma P2. Terminating decimal. I hope the idea it is clear. Generally people will say 0.3 bar is 3 by 9, 0.32. No, actually this is recurring and terminating decimal. Is this idea clear? First we will understand terminating decimal, then we will get into the recurring decimal. After how many digits? After how many digits? After how many digits will the given fraction below? After how many digits will the given fractions below? Given fractions below terminates. Given fractions below terminates. One by one we will do. 1 by 64, 7 by 625, 1 by 400, 13 by 1250. One by one we will solve. After how many digits will the given fractions below terminates? What is that we are discussing? Power of 2, power of 5. If it is power of 2, 1 by 2 power 6. Answer is after 6 digits it will terminate. After 6 digits it will terminate. 7 by 625. 7 by 5 power 4. After 4 digits it terminates. Are you all with me? After 4 digits, it will terminate. 1 by 400. 400 is 2 power 4 into 5 square. 16 into 25 is 500. LCM of 2 and 4. It will terminate after 4 digits. It will terminate after 4 digits. 13 by 1250. 13 by 625 into 4. 5 power 4 into 2 power 1. LCM of 1 and 4. It terminates after how many digits? 4 digits. I hope the terminating decimal idea is crystal clear to you. Terminating decimal. Terminating decimal after dot. Right? Sir, why it is getting terminating? Why? Because 1 by 2. I am multiplying it by 100%. What are the prime factors of 100? 2 and 5. That is the reason when the denominator is taking power of 2 or power of 5, then I am getting a terminating decimal. Then I am getting, it is perfectly divisible. Perfectly divisible. 6 is perfectly divisible by 2, 3.0. 25 is perfectly divisible by 5, 5.0. 100 is perfectly divisible by any power of 2 or power of 5. Why? Because the prime factors for 100 are 2 and 5. I hope the terminating decimal concept is extremely clear to you.